A Cisco device has components similar to other types of electronic devices. It has a Universal Asynchronous Receiver Transmitter, UART, which controls the AUX and console ports. There may be one or two Universal Serial Bus USB ports, which may be used as flash memory. For a switch, an Application-Specific Integrated Circuit, ASIC, controls the flow of data between memory, a CPU, and an interface. Now let us look at the memory components. Read-only memory, ROM, stores the power-on self-test, POST, ROM monitor, ROM-on, and bootstrap. Random access memory, RAM, stores dynamic information, such as the routing table, running configuration, ARP cache, and buffers. Compact Flash and Flash stores the Cisco Inter-Network Operating System, IOS. Non-volatile RAM, NVRAM, holds the configuration file and the configuration register. In the next slide, let us discuss basics of Cisco device. A new switch can provide basic switching capabilities with no configuration. However, a router requires configuration. Until an IP address is configured, a console connection is required to access a Cisco device. In the following slide, let us discuss a console port. A Cisco console port requires a rollover cable with an RJ45 connector. A rollover cable pinouts are 1 through 8 on one side and 8 through 1 on the other. To connect to the console port from a PC, a serial connection with a DB9 connector is used. To access the serial port, use a terminal application on the PC. The serial settings are displayed on screen. Take some time to study it. Let us look at some other types of ports on Cisco devices in the next slide. AUX port was designed for modem access, which is not used often anymore. Not all Cisco devices have an AUX port. Let us now discuss an Ethernet port in the following slide. Ethernet ports connect the device to the local area network, LAN. The port speed may vary from 10 megabits per second to 10 gigabits per second. Cisco has interface cards that provide 10 on 100 capability and can use full or half duplex. Ethernet cables use an RJ45 connector, which is the same connector that is used for console cables. However, the pinouts are different. Let us continue our discussion on Ethernet ports in the next slide. There are two types of Ethernet cables, straight-through and crossover. In straight-through, the pinouts match on both ends of the cable, 1 to 1, 2 to 2, etc. A straight-through cable is used to connect two different types of device, for example, a router and a switch. For a crossover cable, as you can see in the diagram, 4 individual wires are crossed over. A crossover cable is used to connect two of the same type of device, for example, two switches. The exception to this rule is that you use a crossover to connect a PC and a router. Many Ethernet ports are now auto-MIDICs. This means that the port detects the cable pinouts and automatically adjusts between straight-through and crossover. Let us discuss the other types of ports in the next slide. Serial ports are mostly used for WAN communication. Serial ports are not available on a switch. There are many different types of serial ports with different speeds and bandwidth. Cisco markets interface cards for a wide variety of serial applications such as T1 and ATM. Now you are familiar with the hardware in a Cisco device. In the next slide, let us see what happens when a router is powered on. The steps involved in a router boot are important to understand. First, perform POST. Next, bootstrap from ROM. Then, check the configuration register value. This indicates if the configuration file should be loaded or not, among other things. Now, locate and load the IOS from Flash. The router looks successively in Flash, a TFTP server, and ROM, and loads the first IOS found according to the boot order configured. If the IOS is not found, then the router enters ROM-on. You need to use a utility to load the IOS before you can use the router. The same type of procedure now occurs for the configuration file. The router looks successively in NVRAM and a TFTP server for the configuration file. If it is not found, enter the setup mode. If you answer N at the prompt or press Ctrl+C, a default configuration file is created. The setup mode can be used to minimally configure the router so that remote access can be used for further configuration. Let us focus on boot order in the following slide. The default boot order is flash, TFTP, and ROM. This means that the router looks in that order for the iOS and loads the iOS image from the first device that has it. The boot order can be changed with the commands shown on the slide. Take some time to review these commands. Next, let us discuss Router Configuration Register. The configuration register determines how the router handles the iOS when it boots. If it is a hexadecimal 2100, the router boots to ROM-on. If it is a hexadecimal 2101, the router boots the first valid iOS file in flash. If it is a hexadecimal 2102, the router checks the configuration file for a boot startup location. This is the default value. Another part of the configuration register determines how the router handles the configuration file when it boots. A value of hexadecimal 2142 instructs the router to bypass loading of the configuration file. This setting is used in password recovery. In the next slide, let us look at how to use the Cisco iOS file system. The table represents the commands and its functions. For example, the command show flash shows the contents of flash. Take some time to review other commands displayed on screen. In the next slide, let us discuss backup and restore the iOS. When the iOS on a router is accidentally deleted from flash, the router is still operational because the iOS is running in RAM. However, if the router is rebooted, the iOS is no longer available and the router enters ROM-on mode. To restore the iOS, retrieve the iOS backup on the TFTP server. Of course, to retrieve it, you must first take a backup. This is the first step to be followed when initializing a new router. Now let us learn about TFTP Backup. File Transfer Protocol (FTP) and Secure Copy Protocol (SCP), among others, can be used both for backup and restore. However, all Cisco devices support TFTP as a client and as a server. Hence, it is convenient to use TFTP. The following steps can be used to perform a TFTP backup. Use Telnet, SSH, or a console connection to access the router or switch. Ensure that the router or switch is able to ping the TFTP server. Use one of the commands shown on the slide to display the name of the iOS file in flash. The address of the TFTP server, depending on your network, may require full qualification. In other words, specifying the location, directory, and file name. Let us continue our discussion on TFTP backup in the next slide. On the router or switch, enter copy flash, the file name TFTP. You will be prompted with the address or name of the remote host. Enter the address of TFTP server. The next prompt is destination file name. By default, this will show the name of the file you entered originally. Press the Enter key. You will see a series of exclamation points as the file is being transferred. When the transfer is done, you will see the total number of bytes copied in the total number of seconds. You can use the same TFTP backup command for the configuration file as well. Now that you have a backup of the iOS, you can use it to perform a restore of the iOS. Let us discuss this in the next slide. If the iOS is accidentally deleted from flash, do not reboot. Restore the iOS from the TFTP server. Once you reboot the device, the procedure for an iOS restore is more complex. Enter copy TFTP flash. When prompt for the address or name of the remote host is received, enter the location of the TFTP server. At the source file name prompt, enter the name of the iOS file. There will be messages that the TFTP is accessed and the iOS file is loading. Then a series of exclamation points, similar to iOS backup process, are seen as the file is being transferred. When the TFTP transfer is done, enter the last two commands shown on the slide to reboot the device. Restore the configuration file in the same manner. In the next slide, let us discuss iOS licensing. There are two ways to obtain an iOS. Either it is packaged with your device or it is downloaded from the www.cisco.com website. Cisco licensing has two parts. The license for basic features is permanent. For integrated services routers Generation 2 and later, separate licensing is required to activate extra features. The actual iOS image is the same for all devices with the same platform. You pay for and activate only the features that you need. There are two ways to activate licenses, either through Cisco License Manager or manually. Activation through Cisco License Manager is automated and straightforward. Let us look at the steps involved in the manual iOS licensing activation method in the following slide. This procedure is used to manually activate an iOS feature. First, obtain a PAC. This is a cryptographic key. On the router, enter the command shown on the slide to display the Unique Device Identifier, UDI. Browse to the Cisco License Registration portal online. Enter the UDI and the PAC. This will generate a license key file to download to the router. On the router, enter the command shown on the slide. The URL is the location of the license key file. Reload the router. Enter the Show License command. This should show that the PAC feature has been activated. So far in the lesson, the tasks involved in device maintenance have been discussed. Most of these tasks can be accomplished by using remote access instead of a console line connection. In the following slide, let us discuss remote access. Remote access is preferred over using the console line for the reason that remote access uses Ethernet connections which start at 10 megabits per second. The console connection is 9600 bits per second. The two most common remote access methods are Telnet and Secure Shell Protocol, SSH. Telnet uses TCP port 23. This is the default for virtual terminal VTY lines. SSH uses TCP port 22. It is preferred over Telnet because it is encrypted. Let us focus on remote access PC software in the next slide. A management station is normally a PC that a network administrator uses to monitor the network. PC software packages are normally installed on the management station to allow remote access. Telnet is a service provided inherently by the OS. Telnet service must be enabled if this is not the default. There are two options to establish Telnet sessions. At the command prompt, enter the Telnet command or use a PC software package such as Hyperterminal or PuTTY. To use SSH, a PC software package that provides SSH access is required. For example, Secure CRT. SSH also must be enabled as a service on the PC operating system. Next, let us focus on Secure Shell. Only Cisco iOS cryptographic images containing the IPsec feature set support SSH. Typically, these images have image IDs of K8 or K9 in their image names. For later images, you must activate the licensing for cryptography. Each of the target routers must have a unique host name. SSH is automatically enabled on the router after the Revest Shamer Edelman RSA keys are generated. To use SSH, a PC software package that provides SSH access is required, for example, Secure CRT. SSH also must be permitted as a service on the PC operating system. In the following slide, let us discuss local database authentication. For SSH, authentication must be configured on both the source and the target. You can use either local database authentication or server authentication. Here you configure local database authentication. Take some time to review the commands. The username command creates an entry in a local database, that is, only on the specific device. When the device is accessed, the user will be prompted for username and password. Access is denied if either is incorrect. Keep in mind that passwords are case-sensitive. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.